Welcome to Chapter 7, Circular Motion. We're now talking about centripetal forces. So we're going to solve problems involving centripetal force, and to do that we'll first need to look at what a centripetal force is. So, centripetal force is just the name given to the net force acting on an object undergoing uniform circular motion. So we have our ball on a string again, and it's going in a circle. Okay. And our net force, it turns out, will be directed towards the center of the circle, and we just denote it with a C so that we know it's the centripetal force. So we can calculate the centripetal force acting on an object in uniform circular motion using Newton's second law. So here we have Newton's second law again, F equals ma, and this case our acceleration is going to be our centripetal acceleration. So we need to make this our centripetal acceleration here, since it's our centripetal force. And then we can just plug in what we have and give us this new equation for centripetal force that is mvt squared over r. So looking at our ball on a string again, I want to remind you the acceleration is directed towards the center, and now our net force is directed towards the center as well. So without that net force, our object would not have this acceleration. That's why they're directed in the same direction. Also, because of Newton's law, mass is not a vector. Only the acceleration and the force are vectors. So they have to end up being in the same direction, which is what we learned before. So if we did not have this centripetal force that changes our direction, remember, this acceleration is just a change in direction, then we wouldn't have things that travel in circular motion. Let's look at a math example now. So we've got a dog sitting 1.5 meters from the center of a merry-go-round, and it revolves at a tangential speed of 1.5 meters per second. If the dog's mass is 18.5 kilograms, what is the magnitude of the centripetal force on the dog? So we just asked the magnitude because we should know from the fact that this is centripetal motion, that the direction is already towards the center of the circle or your path. So you might remember this example from our first example in the last video. We had the same dog sitting on the same merry-go-round. So before we calculated his centripetal acceleration, and now we're going to calculate his centripetal force. So I need to add a little C there. So we plug in our numbers. I've already written them out here for you. So we got our radius from him sitting there. Our tangential speed is told to us. It gives us the dog's mass, and we just have to find this. So plugging things in, I have 18.5 kilograms times our tangential speed, which is 1.5 meters per second, and that whole thing is squared, divided by our radius, 1.5 meters, and when I plug that all in, we get a value of 27.75 newtons is our centripetal force. Please let me know if you have any questions in class, and I will see you then.